I'm Dhruv Jain. I lead product marketing for our network security and analytics business. Thank you so much for joining VMware at the Security Field Day. I am really excited to be here. I realize all of us would much rather do this in person, but the virtual format has its advantages. Hopefully, this will help us get our network security strategy, product demonstrations in front of a lot more people. I've been in the network security and operations space for many years now at startups, at Cisco, now VMware. And what's really amazing to me is the amount of innovation that's happening in the security space. How security architectures are being completely rethought of around zero trust principles and more. And even in the firewalling space, which is seeing massive change with new distributed models. In this opening session of the field day, I'll walk through our overall network security strategy, specifically in the data center. And the recurring theme that you'll keep hearing is how our distributed approaches completely change the efficacy, the operational simplicity, and economics of data center security. And then in the subsequent sessions, we'll do a deeper dive on each of the specific solution components along with actual real-life demos. And so let's see what's creating this change. From medieval times, we've learned one thing. No matter what you do, no matter how strong those castle walls or perimeter defenses are, someone, somewhere, somehow is going to find a way to burrow in, right? To breach your perimeter defenses. And when they do that, it is not the server or the user device where they land where the damage is done. It's the 48 lateral moves through the infrastructure, perhaps undetected over 9 months, exfiltrating your credit card data, much like the well-known credit union attack. That's where the real damage occurs. And think about this in the real world. If someone breaks into your house, steals your laptop, steals your tax records, you'll be mad. But if someone breaks into your house, walks room to room, sits in that story time with your family and listens to all your conversations, that's unthinkable. But that is what is happening in our data centers today. And so how are attackers actually getting in? Just a couple of years ago, scanning for vulnerabilities and exploiting them, that was a small component. A year later, it quadrupled, becoming a second close among the top 3 initial exploit vectors. Clearly, from the data that we see, we know attackers are banking on finding and exploiting vulnerabilities in your system. Vulnerabilities that you could have patched months ago, but we all know how hard it is to patch in a timely fashion. It's an operational nightmare. And one of the reasons is that there are just so many CVEs to keep track of and deal with. Right? Think of each vulnerability like a window in your house, except this house has a massive number of windows. And invariably, you're going to leave one of them open, leave something unpatched. As an attacker, I could create an exotic zero-day exploit, which is a lot of work, or simply exploit an unpatched Drupal server using Drupal Get-In, for instance, and just take the easy way in. And that's what a lot of attackers do. And so at VMware, we believe that East-West is the new battleground for security. Bad actors are going to get into your network. What we are maniacally focused on is to make it incredibly hard for them to stay inside your network. Now, the reason why people aren't doing a lot of East-West security, that frankly speaking, it's pretty hard to do. In typical data center environments, you have to hairpin all the traffic to dedicated appliances for inspection. And given the sheer volume of East-West traffic, that's just not practical. Operators are forced to selectively inspect traffic. Now, the way we have addressed it is by taking that firewall and breaking it into 1,000 little software firewalls deployed at each workload inside the hypervisor. It's still a single firewall, managed from a single pane, but enables you to have absolute coverage of all East-West traffic. No blind spots. The NSX firewall is wherever your workloads are. And then we do the same thing with distributing the IDS-IPS functionality, the load balancing and web application firewalling. And now, with the integration of the last line acquisition that we bought in the summer of last year, we're moving the behavior-based detection, the network traffic analytics out to each workload as well. And so instead of tapping the traffic and sending copies of it back to some centralized appliance for analysis, we're moving the analytics out to the packets. This is the only fully distributed firewall in the industry with the full stack of access controls and advanced threat prevention capabilities that you expect in any firewall, but all of that in a distributed model. And that is incredibly powerful and game-changing. If we take this firewall and deploy it across thousands of hypervisors running across tens of thousands of cores, we can actually get up to 20 terabits of firewalling capacity. That is huge. But we also deliver that at about a third of the cost of traditional firewalls. Now, when it comes to east-west security, if you don't have the scale, you don't have these economics, you pretty much don't have a viable solution. Just as an example, in one of VMware IT's NSX Firewall deployments, we measured that they're securing over 500 gigabits of east-west traffic. That was technically and economically infeasible for them with traditional firewalls. We deliver not only the scale, but also the price performance economics and better security. And so now let's talk about that last piece, how we deliver that better security. In the data center, when you are trying to protect east-west traffic, there are three critical components that everyone should implement. The first one is segmentation. Now, for those of you who know NSX well, that's where we started. The first generation was about creating network segments in software or these virtual security zones. This solves the foundational problem that prod can't talk to dev, or an app tier in a dev environment can't talk to a DB tier in production, right? And if you already have NSX, implementing this segmentation is extremely easy to do. You go into the management console, create a security group, say for production. You then create the policy that says, say, an environment isolation policy that disallows any traffic between prod to dev. At this point, the network segmentation is done. This requires no network changes. And now, if you tag any new or existing workload as prod or dev, they will be included in the right security groups. They will automatically inherit the policies, and they will be isolated irrespective of which network, VLAN, etc., that they're sitting on. And these policies are not just layer 4. With NSX Firewall, you can use layer 7 constructs such as user ID, application ID as well. And in the next presentation, Brian Haley will show this whole thing and how you bring up the NSX firewalls so easily in demo form live. And so you'll see that in a lot more detail. We believe segmentation of this kind is almost foundational. And if you're not doing it, you're almost being negligent. But you can improve your zero trust posture further by sub-segmenting down to an application level. This is more commonly called as micro-segmentation. And obviously, this is something we pioneered as NSX. Now, while conceptually, micro-segmentation makes a lot of sense, implementing has been hard. And the most common question that customers ask is, what should my policies be in the first place? Most customers need to first discover their application topologies. And so we built NSX Intelligence. This capability within the NSX Firewall discovers all the flows, develops that application topology that you just saw, visualize it, and then with just a single click of that magic wand, it automatically recommends the firewall segmentation policies. You can edit those policies, and when you're ready, with a single click, enforce them within NSX, and then ensure that these policies are compliant with the actual traffic flows. And so if you saw this in just the complete workflow from discovery, visualization, recommendation, iteration, enforcement, compliance checking, all of that is now in one seamless workflow within the NSX Manager.
So on that network intelligence, the NSX intelligence, how long do you recommend you stay in like a discovery mode before you start applying those rules?
That's a good question. And Stein, feel free to jump in if you want to add something. But that's a choice that you have. We provide you multiple time window options, and you can sub-select the set of policies that you feel comfortable with, and only enforce those policies, and then keep expanding the set of policies as you feel comfortable about your, the periodic or seasonal traffic and so on.
Exactly. I would say it really depends on how stable the communication is. Some applications only generate a particular flow, perhaps once a week. Then obviously you would need a little bit more of a learning term. And after you've implemented your policy, any deviation, say we suddenly see a backup flow from one of your workloads that we haven't seen before, we will show that, we will visualize you that as well. And then you have the opportunity to update your microsegmentation policy based on that.
And that's exactly what you see here. You've got these, the color coding on the lines, which indicates, the green indicates that we've got an allow policy and traffic's flowing all right. And if it was, if there was a conflict, that would show up as the different color code, exactly what Stein just referred to.
Just to clarify, the network intelligence bit that we're talking about, that's just application dependency mapping, correct? This isn't something new within NSXT. This has been there for quite a bit, right?
It's been there for almost a couple of years now, a year and a half, yeah. So going on from there, the second step, which is to move beyond access controls and port blocking, which we consider just foundational. Now, in the real world, attackers are continuously getting smarter. They're using stolen credentials. They're using compromised machines. And what they can do is use allowed pathways of communications to move laterally. And that is where the distributed IDS IPS comes in. It's a per hop control that can look at all the flows to identify these attacks. Think of ransomware for a moment. If it is using the SMB port on a file server, segmentation won't be able to stop it because you can't block the SMB port. But our IDS IPS does deeper packet inspection to be able to tell friend from foe and specifically identify that WannaCry flow and block that, right? And another powerful control that this enables is distributed virtual patching. Now, historically, we've all known of virtual patching more commonly in the world at the edge using IDPSs, appliances, or web application firewalls on front-end servers. But that has meant that they couldn't protect the vulnerabilities inside the data center. All the unpatched vulnerabilities inside on east-west traffic would lie open. Now, with the IDS IPS sitting at each host, it can bring this compensatory control surgically to each workload, making sure any unpatched server cannot be exploited. And so that is actually incredibly powerful to help solve the operational challenge of vulnerability management. We think virtual patching should be ubiquitous inside your data center. The other aspect of IDS IPS is people really think they're very noisy and kind of feel that makes them less useful. The reason for this is that traditional IDS IPSs apply all the signatures to all of the traffic, right? But an important thing to note is that IDS IPS signatures are written on a per app basis. They look for specific patterns, for Apache or MySQL and so on, and the vulnerability is based on those applications. Now, because NSX has this intrinsic understanding of workloads, of application context, we are able to take a different approach. We can actually curate the relevant signatures based on the running applications. It really makes no sense to run MySQL signatures on an Apache server or Nginx signatures on an Exchange server. As a result, we can reduce the number of signatures computed on each host by orders of magnitude, and as a result, drastically reduce the false positive rate. And so, what does it take to deploy an IDS IPS here? If you've already got the NSX firewall running, all you need to do is go inside the NSX manager and toggle one switch to turn on the IDS IPS on exactly the clusters, the security groups that you want, right? You can be as specific and as broad as you like. You can use the same security groups that you've created for the access control policies. It's just that simple, right? And later today, Stein will actually walk through in much more detail on these capabilities of our IDS IPS.
If I can ask you a question real quick before I move on. What intelligence source are you guys using to identify malicious packets?
Sorry, can you clarify that some more? What do you mean by intelligence source? You mean signature sets, or are you talking about our threat intelligence capabilities, machine learning stuff?
Yeah, so I was just wondering what you guys were using to identify malicious signatures or packet contents to identify packets as malicious.
Well, it depends if it's signature-based or behavior-based. So signature-based, obviously we have multiple sets of signature vendors that we support. On the behavior side, I'll actually touch on that in the NTA section. We have behavioral models as well. And in the third session, Stein will also talk a lot more about all the anomaly detection techniques, et cetera, that we have as part of the behavior-based analysis, traffic analysis.
Okay, perfect. I look forward to it.
I also have a question. I think it's really smart to reduce the number of signatures that you're testing based on what the node is actually running. But how do you determine that? I mean, if you're seeing port 80, that could be an Apache, that could also be an Nginx or any other web application server. So how do you detect which rules to apply to this?
Yeah, there's multiple mechanisms. Part of it can be creating manual groups of signature sets. Some aspects can be automated. As you saw in, say, NSX Intelligence, we are doing application discovery, right? So that can help you also help us curate the right signatures.
Okay, so there's some sort of configuration dialog where I can choose what I want to apply.
Yes.
Okay. I see Stein nodding too. So
yeah, that's correct. So there's definitely there's a manual component of it. So when you create an IDPS profile, you can choose I want to only include signatures based on Couch database, MySQL, whatever those databases are that you're running, and then apply that to any VM that is tagged with a database tag. Obviously, being VMware, we have a lot of context about the guest. Through VMware tools, through guest introspection, we know the operating system. We know the version of the operating system that is running. So you can then apply signatures based on that. As Ruth mentioned, through NSX Intelligence, we also know the running processes on every workload. And you can use that to then selectively apply the signatures that are relevant to those processes and to the operating system.
Okay, thank you.
I have also a question regarding the IDS. So a lot of IDS questions. Traditionally, if I compare this with traditional models, IDS had a very, let's say, bad reputation when it comes to performance. Of course, in the NSX context, you can scale up with more initiatives. Can you quick walk me through, if I enable the IDS, I guess there will be additional resources assigned, and then from a packet flow perspective, my packet will go to this additional inspection layer before it will be forwarded. How is this reacting if I have more load? So I have some signatures that are going with high CPU load. Of course, the inspection will have a cost, yeah? Can you just scale up with instantiating more of those? Can you do one flow across multiple CPUs? What are the performance capabilities on that end?
Yeah, Dominic, maybe can take this one. Excellent question. So of course, we're comparing a distributed architecture versus a centralized appliance, right? So unlike the traditional model, we're not hairpinning all the traffic from, across the infrastructure to one or more clustered centralized appliance. The distributed IDS only deals with traffic that is local to its own hypervisor. The way that we send traffic to our IDPS engine, the IDPS is not in kernel. It's what we call a user role module. But we're basically, in our fastpath, we're matching classification roles. Any traffic, any interesting traffic to which we need to apply IDPS, we then pump that traffic to our IDPS engine. So, you can be either very selective. Let's say you have workloads that need to meet PCI compliance, and you only want to apply IDPS to those workloads, regardless of which hypervisor they're running on. You can do that. Or you can be more broad and apply it to all the traffic. Obviously, unlike a firewall, which looks at the vice tuple of a packet, with IDPS, we look at the entire flow. So, obviously it's a bit more resource intensive. So, you can, there is a resource impact. The utilization is pretty low on an memory perspective. We're taking up 1 gig of memory for the IDPS engine. From a CPU perspective, the CPU increase overhead of running IDPS at full throughput is around 10 to 15%, depending on the number of cores available, depending on the hardware. And we usually see that the vast majority of our customers are, it's kind of a bit of a secret, but are memory constrained, not CPU constrained. So we see that the typical ESXi customer, the average CPU utilization is only around 20%. So that leaves a lot of headroom for us to run additional services on top of that.
That's awesome, Stein. But I think I'll just repeat one thing that Stein mentioned, which I also took away from the question, was this is not redirecting traffic to some other appliance. This is all running locally on the inside the hypervisor for that host. And that's why as you spin up more workloads or more hosts, it's basically the IDPS capacity is linearly scaling.
Good, but just to verify, last question regarding this. Can you do multi-cores? Or if one CPU is running high, you can just add more CPUs?
You cannot add. We automatically take resources from all the available cores. You cannot, at this moment, you cannot allocate specific CPU resources. You cannot allocate, a specific amount of cores. We take the cores that are available, but our bottleneck is not the CPU at all.
All right, moving on. And so the last of the 3 controls, this starts going into the more behavioral stuff that was the question asked, where IDPS is a per hop control. It's applied on a per host basis. The CENTIA NDR capability, this is multi-hop network traffic analysis and network detection and response. And that's where our acquisition of LastLine comes in, that we acquired last summer. Right? The LastLine technology looks across multiple hops. It will correlate the behavior of a user accessing a server, going to an application, going to a file server. It'll correlate the anomalous behavior across all these hops to determine if there is any indication of malicious behavior. It'll correlate these individual anomaly events into a much smaller set of relevant intrusions. And those intrusions are really what we as a security team want to detect, right? And further, it organizes them in a timeline and mapping these attacks to the MITRE framework that makes them much more actionable and accurate. And you'll see demos of this capability of how we've mapped it to the MITRE framework and showing sort of this sequential chain of an attack going from, initial exploit all the way through reconnaissance, etc., to exfiltration. And Chad will talk through that in the demo as well in the subsequent session. And so the next frontier for this is the evolution into an XDR, right? Inside the, context is king, right, in security. And in the data center, there are really 2 key sources of context. It's the host context and the network context. Now, with our acquisition of Carbon Black, we can actually get really detailed context about the host, right? And so what that sets us up is to have probably one of the few vendors who have leading capabilities on both EDR, endpoint or host context, and NDR, which is the network context. And what's exciting now is that we will be able to pass that context, and that's kind of where the roadmap is going, from the host into the network security devices, such as a firewall, such as our IDS, IPS, and NDR, right, to create this notion of XDR, as Gartner's calling it. And so let's add up all these components that we just went through for security, east-west security inside the data center, right? And then you'll see sort of it becomes a very compelling set of defenses. We start with segmentation, right? Foundational. It's like basic hygiene. Taking it more granular to per application micro-segmentation. And this is an area where we've pioneered, we've had leadership for over 7-8 years. And then we've extended it to getting per hop, signature-based, distributed IDS, IPS, enable virtual patching as well with that capability. And then gone from a single hop to multi-hop network traffic analysis, and then correlation with NDR, and then combining this NDR with XDR, right, to deliver what Gartner is calling XDR, right, extended detection and response. And that entire stack becomes a very compelling set of data center defenses. That is how sort of we are building the strategy. And we give you not only the strength in security, but as you've seen, we make this security extremely easy to operationalize. Right? And the numbers really speak for themselves. We did this analysis. We have an internal tool called DICE with which we do this analysis across hundreds of customers in production to see what this looks like in real world environments. And we find that customers are able to save up to 75% in CapEx, 73% in OpEx relative to traditional firewalls, right? And so that really sums up the overall data center firewalling strategy.